J-Dub.
Well, there's a similar statement we could make about rotating bodies, which is that a torque increases the angular momentum of an object in the direction of that torque. So let's try to figure out those terms. If I apply a force down on this side of the wheel, I create a torque. Now, torque is force times the distance from the rotating axis. You could call it R. So torque is the force applied times the radius away from the turning axis. Now, what's the direction of that torque? Well, we actually use a right-hand rule to define this. And so what you do is you put your fingers in the direction of the radius from the turning axis and curl them in the direction of the force, and your thumb points in the direction of the torque. So the torque is actually out this way at 90 degrees to the force. The force is down that way, but the torque vector is actually pointing out this way. So the angular momentum of this wheel is being increased in that direction. So the more I apply this torque, the more I increase the angular momentum of the wheel in the direction of the torque. So I'm making this wheel have a very large angular momentum out towards the camera, out towards you.
Here he comes again. Look at all the swag around him, around him. All in the sky, flying on the swag dragon. All that swag, flying around my city on the swag dragon. Bars. Here he comes.
Although this method of using reaction torques is similar to the one that is used to stabilize satellites in space, due to gravity, the algorithms used here are very different. With this setup, the cubely can robustly balance around its corner while rejecting disturbances, rotate while balancing, and balance on its edge.
When we place an object on the magnetic disc, the Levitron is even smart enough to adjust to weight changes auto-magically. And just in case your mind isn't blown yet, you can even flip it on its side. Not exactly practical, but definitely impressive. Finally, a display worthy of your most prized possession, the Levitron Revolution.